What we really don't want to see happen is have someone who spent sometimes weeks or months of tests only to realize that they have to throw out their data because of faulty measurement. Hi, my name is Charles from Robotics. Today I'm going to talk about the details of measuring both torque and thrust in an electrical propulsion measurement system. A simple and obvious way is to use a mix of bearings and pivots to separate the torque and the thrust. This was our first idea when we started thrust measurement equipment, but we quickly realized that friction is a huge issue. For this, I have brought a large motor here, which has a stator and a rotor, and the stator and the rotor are attached together using a bearing. And you can see that there's a significant amount of friction in the system. If I push here, I'm going to feel the resistance, but that resistance is not constant. It's highly nonlinear, which makes it difficult to calibrate. This effect is compounded when you have tools that are used for a long time, because there's going to be friction, there's going to be some small plastic deformation in your bearings, and that will worsen over time. You always also have the risk of a shock, which can cause misalignment, and that increases the friction. What we really don't want to see happen is have someone who spent sometimes weeks or months of tests only to realize that they have to throw out their data because of faulty measurement. This is especially problematic if you've made engineering decisions or if you've shipped products based on false data. To avoid those problems, we have designed a solid-state system. So you can see here that in our force measurement unit, we have a front plate, a rear casing, and both are connected with a single block load cell. That means that there's no friction, there's no plate in the system. There's only a very small deformation, which is sufficient to be picked up by the load cells, and that's what gives you the force and torque measurement. There's a drawback to using load cells only in your system, and it's the fact that load cells are more fragile than bearings. To go around that issue, we've done a careful design of our single block load cell that included simulations to make sure that we have the strength required. Even in the event of a complete load cell failure, your front plate would not fly off, and that's because there are safety screws here that have tight tolerances and that will prevent movement even if the load cell was to be completely destroyed. Thanks for taking the time to watch this video. If you have any more questions, don't hesitate to comment below or to send us an email. We should get back to you quickly. Have a good day.